Hello everyone, today I will explain how to draw the influence line using Muller Breslau method. To draw the influence line using this method, first we have to remove the action. The action can be moment, shear, or reaction. So all these requirements can be called actions. Then we place a unit load or unit rotation at the action's point. If we are drawing for shear or reaction, we place a unit load. But if we are drawing for moment, we place a unit rotation at that point. And finally, draw the deflected shape of that beam. Let's draw the influence line for this beam and see. So we need to draw the influence line for the moment at point C. As you see here, there is a fixed support here, and there is a free end here. If we remove the moment resistance here, this point will have a hinge support. Now we have to place a unit rotation since we are drawing for moment. So it's going to be like this. Now let's draw the deflected shape of this beam. Since here there is a fixed support, this means the angle here will be 0. Because as we know, the fixed support resists the moment. So it will not allow the member to rotate at this point. So here, the deflected shape will remain 0. But for this member, there is a free end here, and there is a hinge support here. And as you know, the hinge support allows the member to rotate. Since here we placed a unit rotation here, so the deflected shape will be like this. So this is the influence line for the moment at point C. Now we need to find this value here. Since we rotated the member a unit rotation here, this means the angle here is equal to 1. Now for small angles, this value here, let's call it y, can be calculated by the angle equal to opposite over the adjacent. And we have the angle is 1 and the opposite is unknown, while the adjacent is 2 from the question here. So y equal to 2. So this value here is 2. Now let's find the shear at point C. So when we remove the shear resistance at point C, this means at this point the member will be able to go up and down. And now we place a unit load here and here. And the summation of these two loads are equal to 1, since it's a unit load. And remember that there is a fixed support here, which means the member here will not rotate, so it will stay at 0. While this member, it has a free end here, and it's free to go up from this point. So we will go up. And this is free, so it will go up, and this is the deflected shape of this beam. Now this is the influence line for the shear at point C, and the value here is 1. Now let's go ahead and draw the influence line for the vertical reaction at A. So let's remove the action. So this beam will be able to move up and down at point A. And replace the action with a unit load. Now because of this unit load, the whole beam will be able to go up, and the deflected shape will be like this. And this value here is equal to 1. And that's it. Thanks for watching.